Okay, so that was good. We've got a multimeter on there now. So what I want to do now is I want to introduce you to an oscilloscope. Now, the oscilloscope isn't going to be much good on this circuit because this circuit's DC. But nevertheless, we can still use an oscilloscope. So, first thing I do is click on the multimeter, delete it. Don't want that anymore. Fed up with that. Go back to the right hand side, and if you scroll down, you can see multimeter, function generator, wattmeter, oscilloscope. We'll have one of those, so that's the fourth one down. Right, third, 1, 2, 3, 4. Fourth one down. Take the oscilloscope and put it in the drawing area. Bang. Now if I double click on the oscilloscope, we actually see a display. There is another oscilloscope that actually looks like the ones on your desk, but you can find that for yourself. So there's our oscilloscope. It's not wired up yet, so let's do some wiring. And I'm going to connect across to here and down to here. Onto that node there. And now I want to run the circuit again. So I go up, click the run button, and look what happens. I get a straight line. Well, I would get a straight line because that's what DC looks like on an oscilloscope. It looks like a straight line. So let's get that back to where the 5 volts was. So I'm just going to stop my simulation. I'm going to change the 2K I had here for a 1K. So I should get 5 volts coming out now, 10 volts going in, 5 volts dropped across R2, 5 volts dropped across R1. So, lo and behold, there it is at 5 volts. If you look down, I'm on channel A. Channel A is 5 volts per vertical division. Look at my cursor. The time scale doesn't matter because it's just a straight line. And now we're using an oscilloscope to be able to do a measurement for us, which is a DC measurement. Okay, I can see, everyone I can see here is doing that absolutely fine, so no problems at all there. Good stuff, right? So you now know how to get hold of components, you know how to pull components into the drawing area, you know how to perform measurements with virtual tools, so multimeters, oscilloscopes, these kind of things, and you know how to run a simulation, which is to press this magic button here. Now you must remember to stop the simulation once it's running, because otherwise it'll affect other things which are inside models. Okay, now DC, dare I say it, is for babies, because DC doesn't change over time. Now really advanced electronics comes into when you start playing with things which are alternating with time. In other words, what we want is, instead of a battery on the input, we want some kind of signal generator. Now the simplest form of signal to comprehend really is a sine wave. Type of wave that you see on the ocean and that kind of stuff. It goes up and down quite regularly, nice and smooth. What would happen if we put a sine wave into that circuit? So if I delete the 10 volt battery and I put a 10 volt sine wave generator in it, let's do it. Okay. Let's do just that. So what I can do, instead of deleting, and this is a powerful trick, if I hit that and I hit delete, don't do that. But if I do hit that, I lose all the wiring that I've done, and it takes time to put it right. What I can do is I can right click, and I can say, replace component down here. Replace components. And then I go in here, and instead of taking DC power, I can click on AC power, which is that kind of round thing with the plus and minus and a wiggly line in the middle. Now I click OK. And suddenly I've replaced my DC source with an AC source. You could have done it over here on the right hand side by using a function generator. That's another way of doing it, and I'll just open one of those so you can see what a function generator looks like. So here's my function generator. I double click and you can see I can change the frequency, the amplitude and all the rest of the stuff. But it does the same job as the thing that I just put in there. I'm going to delete that. So now if I look at this, we said we want the same input as we had before. Well, we had 10 volts before, didn't we? So let's have 10 volts RMS going in here. If you want to know what RMS is, I can explain offline to you. So you've got RMS 10 volts going in there, that's fine, and we've got 60 hertz. Well, let's just take a nice number. Let's take 1,000 hertz, okay? So we're going to make this 1,000 here, or 1 kilohertz as it's known. Click OK. Now we're going to run it, and what we should see is we should see a sine wave output. And lo and behold, we do. I recommend that on the oscilloscope you select normal as your trigger mechanism down in the right hand corner there. And the other thing that we can do is we can change time. So where it says time base on the bottom left hand corner, look at my cursor, what I can do down there is I can sample a bit quicker, look at some smaller chunks of time, and then I can start to see the waveform. So play about with that time division, and you can see that you can zoom into the wave, you can zoom out from the wave, and so on and so forth, yeah? Now the potential divider that we had is still working, because I put 10 volts in RMS, and actually what I'm getting out is about half of that, because half of it has been dropped across R2, and half of it has been dropped across R1. So just as I did before, if I now change this ratio, and I'm going to be quite radical now, and I'm going to say I'm going to make R1 10K, 10K, and the other one 1K, what I would expect to happen is I would expect that waveform to become very small in size. Let's try it. So I've gone 10K on that, 1K on that. Ready? Look, it's time. Yeah? Yeah. So that's true. The potential divider works on AC just as well as it works on DC. Let's stop the simulation. Let's do the other way around now. So make that 1K. Don't need to make this 10K, but let's make it quite big. Let's make it 5K. Okay, run it. And look, that's now bigger than the waveform that we had before, because most of the voltage is dropped across R2 and not much of it is dropped across R1. So I can use a potential divider to change the amplitude of an alternating current waveform. Okay? I'm going to stop that, and I want you to play with that for the next 5, maybe 10 minutes, because I want you to get the hang of driving that virtual oscilloscope. Okay, I can see most of you are there, but nevertheless it would be good if you had a practice at it.